In this video, we'll be looking at related rates problems. Step 1, make a drawing of the situation if possible. Step 2, use letters to represent the variables involved in the situation. Step 3, identify all rates of change given and those to be determined. Step 4, determine an equation that both A involves the variables from step 2 and B involves the derivatives from step 3. Step 5, differentiate implicitly the equation from step 4. Step 6, substitute all known values into the differentiated equation. Step 7, use algebraic manipulation if necessary to solve for the desired unknown. For example, a cylindrical tank with radius 5 meters is being filled with water at a rate of 3 cubic meters per minute. How fast is the height of the water increasing? We'll start by sketching the cylindrical tank. We know that the radius of this tank is 5 centimeters. That is given in the initial information. We also know that it's being filled with water. So we have a line where the water level is. Let's call that H. Other information that we're given is the 3 cubic meters per minute. That is dV dt, the derivative of volume with respect to time, or the rate of change of the volume. dV dt is given to us as 3. And notice we're looking for how fast the height of the water is increasing. That is another rate of change, in this case, the rate of change of the height with respect to time. That's what we're looking for. Next, we need to figure out which equation to start with. Notice that we're dealing with the volume of a cylinder. We know that the volume of a cylinder is pi r squared h. And notice information that you're given. The radius is 5. And notice that's staying consistent. The radius in this problem never changes. So since it's staying consistent, we can go ahead and replace r with 5 at this point, giving us the volume is now 25 pi h. Once we have the equation with all of the information plugged in, we can now implicitly differentiate this with respect to time. Take the derivative of volume with respect to time. The derivative of v is 1 times dv dt. That's using the chain rule. And then we have 25 pi. The derivative of h is 1 times dh dt. Again, using the chain rule. After you differentiate implicitly, see if there's more information that we can plug in that we are given. And we can. dV dt we know is 3. So let's replace dV dt with 3. And our ultimate goal is to isolate dH dt. We can do that now. Divide both sides by 25 pi, and we get dH dt is 3 over 25 pi. And the units there are meters per minute. The rate at which the height is increasing is 3 over 25 pi meters per minute.